All right, in our next problem here, we're asked to plot some points, connect them with segments, and then sort of asked what do all these segments have in common. So I'm looking at our problem packet here, make sure I've got everything. Yeah, what do they all have in common? Okay. So I plotted three example ones here. So from from 2 comma negative 1 to 11.4. From 3.21.1 to 12.26.1, and then from e comma square root of 3 to e plus 9 comma square root of 3 plus 9. And this value e, by the way, is the base of the natural logarithm. It's a number that's, I should put approximately 2.7183, but it goes on. And the square root of 3 is approximately 1.7321 ... So, okay. All right. First of all, just as a note for graphing, if you need to graph something that's like 3.2, 1.1.
Tyshana Coltrane, please come to the main office. Tyshana Coltrane.
There you go. You're just going to have to approximate where that is. So 3.2, it's a little past 3, and 1.1, it's a little above 1. If you have to graph something like square root of 3 or e, 2.7, it's closer to 3 than it is to 2. Just kind of estimate a little bit, all right? Okay. So, we're asked what they all have in common. If you look at them all, they all look kind of the same, just in different positions. And that's exactly what we're supposed to observe, that each of these is the same in a sense, but their positions are all different. All right, here's what we're looking at. If I look at my vertical change, and I look at my horizontal change as I travel from one point to the next, and remember, change is always end minus start equals change. End minus start, or to minus from. Here's where you're coming from, here's where you're going to, beginning, end minus start. So our change in y, we ended at 4. We began at negative 1. So our change in y is a positive 5. Our change in x, we ended at 11. We started at 2. So our change in x is a positive 9. Let's go down here to the next one. So here, I look at here's our change in y, and here is my change in x. And by the way, I'm talking about the change in y and the change in x are just measurements. They're not actually line segments. The dotted lines are just measuring how long something is. So I'm traveling from 1.1 to 6.1, that's our y-coordinate, so end 6.1 minus start 1.1 is 5. And then down here, our change in x, we end at 12.2 minus start 3.2 equals change, which is 9. So the horizontal change and the vertical change are the same as the last one. And then here, so same thing. See, I'm going to come across here. Here is our line that measures our vertical change. Here's a line or segment, I guess, that measures our horizontal change. And here, for our vertical change, it's square root of 3 plus 9 is our end. Square root of 3 plus 9 minus our start, which is just square root of 3, equals, well, negative square root of 3, positive square root of 3, they cancel each other out, and we're just left with 9. So our horizontal change is positive 9 spaces to the right. Wait a minute. That was our... What did I just do? Pause for a second. I did something terribly wrong. Yeah, I just realized that I am talking about, hold on. All right, so here is the segment that represents our vertical change, which is square root of 3 plus 5. And that's where our end is, minus square root of 3. And the two square root of 3's, they just cancel each other out, and we're left with 5. So our vertical change is a positive 5. As for our horizontal change, we end at e plus 9, and we're subtracting our start, that's e, and the two e's cancel out.
Anthony Stewart King, please come to the main office. Anthony Stewart King.
And we're left with just 9. So our horizontal change is 9. So in every case, our horizontal change and our vertical change are the same. They're both 9. And this is, when we talk about a horizontal change and a vertical change, what we're talking about is a vector. A vector is just a movement in the grid. So far left or right, so far up and down. So a vector is a horizontal change and a vertical change put together. And we would represent this particular vector like this. We would say 9, 5. And we would use either these pointy brackets, or sometimes you'll see people write them like this. All right? But we don't write it with the regular curvy brackets, okay, because that looks too much like the 0.9, 5. And all this represents is an amount of horizontal change and amount of vertical change. And that can occur anywhere in the grid. It could start here and end up here, or it could start here and end here, or start here and end here. If you want to draw your own, right, your own thing, so I'll go here, and I'll put my, there we go. So let's see. I can just pick some random old point, like right here. This is -1, -2. And if I want to represent the vector 9, 5, I just move 9 spaces forward. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I go up 1, 2, 3, 4, 5. And here's my representation of that vector. Okay. And see, this coordinate is 1, 2, 3, 4, 5, 6, 7, 8, 3. So I've just created a new representation of that vector. These all represent the same vector because it's the same horizontal change and vertical change from beginning to end, even though it occurs in different places on the grid. It's the same amount of change. If I wanted to check, for example, if a pair of endpoints, we find here, there we go. If I wanted to check to see if a pair of endpoints represents that vector, then I would just have to calculate my horizontal and vertical change for each. So for example here, if I'm traveling from here to here, remember change is always end minus start. So for our horizontal change, it's 7 minus -2 equals 9. And our vertical change is 14 minus 9, which equals 5. And that represents the vector 9, 5. So check. Works. Take this point here. Let's see. Our horizontal change is 9 minus 6, which is 3. And our vertical change is 5 minus 2 equals 3. So this represents the vector 3, 3. So not the 9, 5 that we were looking for. Here, if we ended at this point here, it's 0 minus -9, which equals 9. And our change in y is 0 minus -5, which is positive 5. So this represents the vector 9, 5. So check. And the last one, we have 6 minus -15, which is 21. And our change in y is 9 minus 4, which equals 5. So this represents the vector 21, 5. So not the 9, 5 that we were looking for. So to tell whether or not 2 points represent the vector we're looking for, we just find the horizontal and vertical change from the first point to the second. Remember, change is always end minus start equals change. And then we just see, is it the horizontal and vertical change that we're looking for represented in this vector form. Also be careful with all these. Anytime you're subtracting negatives, it's a great opportunity to make mistakes. Be sure to use your calculator if you need to. So don't allow some silly arithmetic mistake to mess you up here. Right? And that's vectors in a nutshell. A vector, again, is simply a combination of horizontal and vertical change. It's a movement in the plane. We usually represent it using either these pointy brackets or brackets like this. The first number in the vector represents the horizontal change. It can be positive or negative. Positive is to the right, negative is to the left. And the second number represents the vertical change. And vertical change is either up positive or down negative. That's a vector.